Okay, part two, if you will, of this Jessup storm in central Florida today on the 20th of April 2020. We have the first part, I showed you the 500 millibar chart. We have a series of strong short waves spinning around well-developed baroclinic low sitting over the Great Lakes. And it's going to be spinning short waves all through northern Florida, through central Florida throughout the day. And here's the Weather Prediction Center's front forecast chart valid for 8 p.m. local or 0Z, about 12 hours past that 500 millibar chart, what we were looking at. So that front only really proceeds out of, remember it was running through the southeast corner of Georgia and the northeast Gulf. So it moves about 90 to 100 miles in 12 hours. So roughly moving at about 10 knots or so. So it's going to be kicking up problems for northern half of Florida throughout the most unstable parts of the day as heating continues to increase. All right, so we left off at 15Z, and this cell now gets, you can see the inflow notch maintains. National Weather Service issues a tornado warning. That's a severe storm. Northwest Seminole County. That one's active from 30 past, looks like. So they're issuing a tornado warning on this thing. And it looks like it has slightly different storm track than the severe thunderstorm overall. So we'll rearrange our storm motion here. I'm going to right click on the tornado box, set storm motion from the warning, 259 at 43. Not a whole lot different. Kind of takes it off of Sanford a little bit there, but it kind of in the wrong direction. It'd be better if it pointed south, but still kind of puts them in a rough spot. So we took a look at some cross-section action there. We'll shoot another one through that inflow notch, see how it looks, if we still got our boundary weak echo region. And we're pretty far from the radar, so we're missing a lot of data. It's called below beam effect. So the lowest cut can only see this low in the atmosphere, so about 8,000 feet where we're at roughly. But we can, as we saw earlier, we can adjust our cross-section, see if we can max it out. So we're still looking at a weak echo region here. You can see the kind of shelf action there. So that's a strong updraft. We'll take a look. We'll go 2 panels here and we'll line up storm relative velocity panel alongside the base reflectivity, see how it looks. So we would be looking for a couplet somewhere around about right there. I'm going to place a marker right there, see where it shows up. So it's showing up over here on SRV in the right spot. There's so radar's down to the southeast corner, bottom right corner of the image. And so we've got outbounds here. Red ones are flowing towards the northwest. Inbounds, the green ones are heading towards the southeast. Let's see what our max inbound is. Looks like about right there at 7,000 feet. We've got about 30 knots, 28 knots. And on the outbound side, we've got 37. So overall DV, delta velocity, the fourth line there on our shear tool is showing us 65 knots. So that's equivalent of about roughly 33 knots inbound and 33 knots outbound if you had a symmetric couplet. So this is a cyclonic couplet, and it is a meso. The endpoints are only 3.49 nautical miles apart. I could probably skinny that up a little bit if I needed to, but that's well within the mesocyclone range. So 5 nautical miles or less than the endpoints. We need 10,000 feet of vertical extent. We're starting out at 7,000 feet. And so we're going to bump this up and look up through 17,000 feet, see if we got continuous layer of rotational shear of at least 50 knots. And we got 65. 50 knots is the minimum. That's a minimal meso at any range. So anything above that's gravy. So I'm going to bump it up using the arrow key, go up one elevation angle, and we got to kind of move our points. And we'll see our max inbound. It's like 32 there, 32 there, 28. We'll use this 32. I'll place my marker there. And hold down control, mousing over. There we've got delta V still 64 knots, and we're up at about 9,000 feet, so only a couple thousand feet through 2 cuts. Our range, our diameter is less than 5 still, 3.81, and we'll take it up another elevation angle, still marking our altitude. So we're up at, this looks like about 11,000 feet, so we're about halfway where we need to get our 5,000 foot of vertical extent. Place my marker and look for my max outbound. There's 20. Looks like that's about it. Just looking to see if we got a good gate-to-gate shear a little bit in through here, maybe, but not much. There's 20, so we still got 59 knots, at least a mezzo. Go up another elevation angle. 36, 38, 38. We'll use this one right here. We'll use this 36 knot. It'll still get us into ballpark. Place marker. And we've got 53. So we're up at 15,000. One more cut. We should do it. We should have our 10,000 feet of vertical extent. So looking for our max inbound, 45. Place the marker. We don't need much on the outbound side. There's 8 knots. 0.74. So over 50, we're up at almost 20,000 feet. So we got 10,000 feet of vertical extent and at least a minimal mezzo. So this thing's got a manually verified mezzo in it. So remember that 90%, 80 to 90% of the storms with manually verified mezzos can produce severe. Notice the reflectivity signature over here on the left. That's sort of a donut hole there. So that's going to be our bounded weak echo region. There's your updraft, and it's surrounded, it's bounded by higher values. So let's quickly run us a volume section on that in volumetric mode right there. Start about in the middle. We'll draw the box out so we can see kind of the whole storm. So here's our inflow notch area right in through here. A little carried away there with the zoom. Sorry about that. It looks like we do have weak echo region, but not quite seeing the bounded weak echo region. Let me back off some of that. Turns it. There we go. There it is. So I bumped it up to about 51 dBZs, and now we can see the cavernous bounded weak echo region in there. So inflow notch in the horizontal down at the surface coming in from the southeast here. It's got to go somewhere. It goes up and it continues to grow. More unstable air we're drawing into the storm, stronger the updraft's going to get, and this is going to become more pronounced. So we get our bounded weak echo region in there. So it's the volume section is showing us a little better performance on the beware than the cross section is in this case. So cross section's kind of hard to hit the right spot sometimes, but the volume section covers a broader area, a little less res. But so storm's got manually verified mezzo and about a weak echo region in it. Storm motion's 43 knots, so we got plenty of ingredients, results, indicators from this storm to want to have a tornado box, a tornado warning out in the storm for sure. So let's rearrange let's go down here in the right corner and do a storm track, see how we look there for Sanford. Still in the danger zone for them for sure at the airport there. All right, so another couple volume scans later, and we're still in business as far as having tornado on that storm.